My name is Graham Herrera Murphy. I am going to be explaining to you guys the characteristics, capabilities, and general information about the armor-piercing, fin-stabilized discarding sabot round, otherwise known as APFSDS. It's a 120 millimeter tank round, first fielded by the U.S. Army, and it's now being used by our partner nations as an anti-armor round. Right, so this is a basic schematic. It's a 100 millimeter tank round with a subcaliber penetrator. So subcaliber meaning that the penetrator is not the width of the barrel, right? So the penetrator, the thing that actually hits the target, is this long, thin thing in the middle of this drawing, not all this chunky, weird-looking stuff on the outside. The chunky, weird-looking stuff on the outside is aluminum, and it is what actually seals the barrel so that the gases from the tank gun can push the round forward. And that is accomplished by something called an obturator, which is what engages with the rifling, which makes the round spin. But it's also stabilized by its fins. So its fins stay on. This is integral to the penetrator. The aluminum sabot, so the sabot is actually what is discarded, all this stuff here, engages with the rifling, the round leaves the barrel, and then all of this aluminum around here sheds away, and then you're just left with the penetrator going very, 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 very fast. The penetrator is also very dense. It's made out of depleted uranium, which is a byproduct of enriched uranium, which is used for weapons and for nuclear power. When it's depleted, it is just extremely heavy, extremely dense, and it's used in loads of applications where something that's dense is very needed. It's mildly radioactive, so the target tank, or the target, after being hit with this round, will be mildly radioactive because the depleted uranium goes everywhere. Cool. So let's talk about some characteristics, then we'll talk about some capabilities, and then I'll show a video of what it looks like when this thing is in action. All right, so characteristics. Total weight of the whole sabot is 18.6 kilos. Right, so it's about 40 pounds. It's a big old thing. And that includes, there's actually a tank round that goes on the back of this with a bunch of propellant and a steel case. So this is actually what goes down the barrel, but this stays in the chamber after it expels it. So the total weight of all that stuff is 18.6 kilograms. And then the total weight of the penetrator, which is just that heavy thing that actually hits the tank, is 4.6 kilos. The muzzle velocity, so how fast it's going when it leaves the barrel of the tank, is 1,670 meters per second, which is a very large number. For context, your car moves at about 1,609 meters per minute when you're driving 60 miles an hour. So this is the same, but meters per second. So it's going about 60 times faster than highway speed cars. And like I said before, the penetrator is made out of DU, or depleted uranium. Cool. Capabilities. This bad Larry will go through 540 millimeters, which is a little bit less than 2 feet of rolled homogeneous armor. So basically just standard tank armor at a range of 2,000 meters. Excuse me, I wrote 200 here. 2,000 meters. From 2 kilometers away, it'll go through 2 feet of steel. So it's a very, very powerful weapon. I'm going to show you some slow motion video of this being used, and then we can talk about it. Okay, so now we see a slow motion tank round of an armor-piercing, fin-stabilized discarding sabot. You see the sabot gets discarded, the penetrator, which is made out of depleted uranium, traveling through the air, moving at roughly 1,670 meters per second. So just a tremendous amount of energy. Again, another slow motion shot, slightly different shaped penetrator. And then this is what it looks like when it hits a target. So there's no explosive. It's just kinetic energy. There's no explosive here. So all that fire is just the metal getting vaporized from hitting the target so hard. Amazing. So that's what it looks like in use. We'll do some quick math as to what the energy delivered to the target by the penetrator is, and then that's it. So this is a kinetic weapon, meaning that the only energy that the round has when it hits the target is kinetic from motion. And the equation, if you remember physics 1, is 1/2 mv squared. So Ke is equal to 4.6 kilograms, which is the weight of the penetrator, times 1670 meters per second, which is the velocity squared, divided by 2. And so 1600 squared is a big number, 4.6 is a regular size number, and then 2 is a regular size number 2. So you just get a very large kinetic energy. It works out to 4.61 times 10 to the 6th joules, which is a phenomenally large number. Okay, barring any questions, this is a 120 millimeter APFSDS tank round. Thank you for your time and attention.